Okay, here we're reacting C2H4 with oxygen to produce CO2 and H2O. We're combining 2.7 moles of C2H4 and 6.3 moles of O3, and they would like for us to predict how many moles of water are made. So we're going to construct our BCA table by first writing down the balance equation. And you'll notice in this one we do have two products, but we treat it like any other problem. Products are always going to be 0 at the beginning, no matter how many you have. Okay, so we take 2.7 moles C2H4, 6.3 moles of O2, and both products are 0. But they both get their own column because they're different chemicals. Our change row, I don't know what the limiting is, but we're going to test that first one. Let's say our first reactant is limiting. That means I need to subtract all of its value, 2.7. And that 2.7 gets copied over to all the other boxes. And they get fractions. Okay. Now for the fraction, that mole ratio, oxygen, its coefficient is 3. And C2H4, its coefficient is 1. So that mole ratio becomes 3 over 1. So real quickly, I'm going to calculate 2.7 times 3. And I get 8.1. And you pause, okay, and you evaluate if you have enough oxygen gas. There are only 6.3 moles of oxygen before the reaction. Yet our change says 8.1. We don't have enough oxygen to complete the reaction in this manner. So that means oxygen is a limiting reactant, not C2H4. So this change row is invalid. This is not going to be our change. So we're going to cross it out and pretend that it's not there. We now know that your LR is going to be O2 because we didn't have enough of it. So your limiting is O2, so we're going to subtract all of the starting value of that oxygen, 6.3. Since O2 is a limiting reactant, its value gets copied to all the other columns. And all those values get multiplied by that fraction of your mole ratio. So for C2H4, its coefficient is 1. The coefficient of your limiting is always the denominator. So our LR we said was oxygen, and I'm going to circle its coefficient of 3 for emphasis that the 3 goes in the denominator. We're going to calculate this real quickly. 6.3 divided by 3, I get 2.1. And I'm going to repeat this process for all the other chemical species in the reaction. For the CO2, its coefficient is 2. The limiting reactant coefficient is 3. And for the water, its coefficient is also 2. And the limiting coefficient we said was 3. Okay, so for this calculation here, we're going to do 6.3 times 2. Divide that answer by 3, and you get 4.2. So both of these will be 4.2. The after row is the combination of B and C together. So C2H4 starts as 2.7, and we are minusing 2.1. So that's going to be 0.6 moles of C2H4 that are left over. Your oxygen is limiting, so it should be 0 at the end. And just to show you, 6.3 minus 6.3, yes, that is 0. And your carbon dioxide starts as 0, and you're adding to it 4.2. So 4.2 moles of CO2 are made. And we'll repeat that for the water. 0 plus 4.2 gives us 4.2 moles of H2O that are made. I'm going to highlight our limiting column for emphasis and point out a couple of key things. Number 1, the limiting value is always 0 after the reaction, and that's because you used all 6.3. And that 6.3 is transferred to all the other change columns. Finally, the coefficient of oxygen was 3. So the coefficient of your limiting reactant is always going to be the denominator in the mole ratio fraction. So 3 coefficient for oxygen, I carry that 3 to the denominator everywhere else. Now to sum things up, part A, how many moles of H2O are made? Looking at your BCA table, 4.2 moles of H2O are made. Part B, what is your limiting reactant? Again, look at your BCA table. Your limiting reactant is the one that's 0 at the end. We said that was O2. And then finally, part C, the excess reactant. First of all, it has to be a reactant. So the left-hand side of the arrow. You have extra C2H4. So that means C2H4 is your excess reactant.